All right, today we're going to look at the conic section called an ellipse, sometimes also called an oval or things like that. So when we think about an ellipse, how we're going to define it is going to be the set of points whose sum of distances from two fixed points, and we'll call these fixed points foci, is a constant. So let me go ahead and explain what this definition means. So again, we have a bunch of points that go along the edge, but how do we find where those points are? Well, we have two fixed points on an ellipse, and they are somewhere outside the center of this ellipse. The center is this point here. So these are what we call foci. So these ellipses, if I take the distance from these foci, so let's take this distance here, we'll call it D1, and we'll take the distance from this foci, we'll call it D2. If I take D1 plus D2, I'll get some constant, we'll call it K. Well, if I take another point on this ellipse, let's say I take this point way over here, then this distance here, we'll call it D3, and this distance here, D4, well, D3 plus D4 would equal that same constant. So the distances from any of these two fixed points from the edge of the ellipse is always a constant. Ironically, we really don't care what that constant is, we just know it is the same for any of these sum distances.
So some of the most important thing we'll be looking at in our ellipse is some of the parts of an ellipse. So let's go ahead and draw another ellipse here, and I want to kind of just draw some parts of the ellipse that we'll keep talking about. So an ellipse is longer in one direction than the other. So the longer axis we call the major axis. So this could be vertical or it could be horizontal like in this case, and we call the shorter of the two axes the minor axis. If they were the same, then it would of course be a circle. The endpoints of the major axis we call vertices. So on both sides we have a vertex on the edges of the major axis. On the edges of the minor axis we have what are called covertices. And then we have those two magical points we talked about called foci. Those foci are in the ellipse on the major axis. And then we have our center in the center. So a lot of things happen on the major axis, the foci, the vertices, the center. The minor, just really the center and the covertices. We also have different labels for how far away these are from the center. We're going to call the distance from the center to the vertices A. We're going to call the distance from the center to the foci C. And we're going to call the distance from the center to the covertices B. Those are just arbitrary definitions of how far each of those are. So when we start making our equations for ellipses, those will be very important. So when we're looking at the equation of ellipse, we have a couple different equations, and you'll see they're very similar, only one minor change. So first we'll start with the ellipses that are centered at the origin, like this one. So this is an equation of an ellipse centered at the origin with the major axis along the x-axis. This basically means it's longer horizontally. So your ellipse is going to look something like this. Now, in this case, we always typically say A is bigger than B. So our equation for the ellipse is x squared over a squared. And remember, A is the distance from the center to the vertex, the vertices on both sides, plus y squared over b squared equals 1. And b is that distance from the center to the covertices. So a is greater than b, and then very importantly, we have this relationship between a, b, and c. For an ellipse, this is always b squared equals a squared minus c squared. So the big thing you want to notice, and I always think about it this way, since A is always bigger than B because the distance from the vertices are going to be larger than the co-vertices, since this is larger, it's always going to be under your major axis. Since it's under the x here, the major axis will be for x. When we look at the reverse of this, when it's longer vertically, then we'll have the A, the bigger number, under y. So whatever's bigger on the bottom is going to be what your major axis is. So if we draw this, just to kind of, just put this all out there. So we have our center. So just remember A is going to be the center to the vertices, and these vertices are out here. We're going to call B the center to the co-vertices, and our co-vertices are here. And we're going to say C is the center to the foci, and those are going to be here. And then don't forget, very important, we know these are related because b squared equals a squared minus c squared. So we use this relation a lot as we're doing these problems. So this first problem says, let's find the equation of an ellipse with a focus at -7, 0 and one vertex at 10, 0. So what I would do first is I would go ahead and draw an axis. I have a focus, which is just a singular of a foci. I have one of the focus at -7, 0. And I have a vertex all the way out here at 10, 0. Now this is important because what I know now is I know the major axis has to be the x-axis because the vertex, remember the vertices are only on the major axis. The co-vertices are on the minor axis. So I also now need to know, can you tell me what A is, can you tell me what B is, and can you tell me what C is? Well, I know A is the distance from the center, and it is centered at, I didn't really put this, but we're going to assume it is centered at the origin. So if it's centered at the origin, then A is going to be 10, because it's 10 units from the center to the vertex. We know the center to the foci, one of the focus, is 7, because you basically go backwards 7. What I don't know is I really don't know how far it is to the co-vertex. But to do my equation, the ones I really need are A and B. So what I'll do is I'll use that little relation I know that B squared equals A squared minus C squared. So B squared will equal 10 squared minus 7 squared. So B squared equals 51. So B to the square root of 51. So the square root of 51 is going to be my B. But since my major axis is the x, when I do my ellipse centered at the origin, x squared and y squared equal 1, then I'm going to put the a, which is my bigger number, under whatever the major axis was. In this case, that's going to be x squared. So I'll put 10 squared there, and then under y, I'll put square root of 51 squared. It's always a squared and b squared. So the equation of an ellipse with these 2 points is going to be x squared over 100 plus y squared over 51 equals 1. So if you were to graph this, obviously not in a graphing calculator because that would be really difficult to get y by itself, then this would give you that ellipse with that vertex and that focus. So let's look at an example where we have a equation and we're trying to graph it. So the first thing I wanted to see, I always like to see what is my major axis. Is it going to be x or y? And I'd like to pick out the center. Now this is in the form. Typically you have your transformations with the x and y if it's going to have a different center, which we'll see in a little bit. So the center is 0, 0. The bigger number is under the x. So that is going to be our major axis, is the x-axis. So the other big things I see here, remember we always like to know what A, B, and C are. So A is the distance from the center to the vertices, and since this is A squared, I know A is 5. B squared is 8, because it's the smaller of the two. So B is the square root of 8, which is 2 square root of 2 if I simplify, which is approximately 2.83, I believe. I don't really want the decimal, but just so I have an idea where it'll be on the graph, probably welcome to have that. So I don't have C. C is not given in the equation, but remember, we have this nice relation that a squared equals b squared equals a squared minus c squared. So b squared is 8. A squared is 25 minus c squared. So if I solve this for c squared, I get negative c squared equals negative 17. I could just make both sides positive by divided by negative 1, and then taking the square root. So c is going to be the square root of 17. Square root of 17 is about 4.12, I believe. So those are my numbers. Now I like the exact numbers, but the decimals will help me out. So I am going to find the graph of this ellipse, and I'm going to try to write the ordered pairs for all these points. So I not only want a graph, but I'm going to go ahead and give you the exact ordered pair for the vertices, the co-vertices, and the foci. So first I'll start with my center, which is at 0, 0. Let's put a little C there. And the major axis is on the x-axis. That's really important because my distance is going to be 5. So I'm going to go up 5 units on each side to get my vertices. That's going to be real simple. My vertices are going to be negative 5, 0, and 5, 0. Now B is my co-vertices. So that's going to be up and down about 2.83 on the minor axis. So that's about like here and about like here. Those are my co-vertices. So the co-vertices, it's up and down 2 square root of 2, so that's going to be 0, 2 square root of 2, and 0 minus 2 square root of 2. Now I can certainly graph my ellipse now. I really don't need to graph the foci to do so, but I'll go ahead and put them on here. So they're about 4.12. They are also on the major axis. The vertices and the foci are always on the major axis. So they're my foci. So my foci are going to be something 0 because they're on the x-axis. And that something we know is square root of 17. So square root of 17, 0, negative square root of 17, 0. So if I go ahead and try to draw my ellipse, it's going to look something like this. I think I made that bottom a little too low, but you get the idea. So there's my ellipse. Those are all my points. Done pretty much top to bottom. So when we're looking for the major axis to be the other direction, not much changes. As you can see here, the only things that really change is now like the bigger number A is now under the Y, and that's because the major axis is going to be along the Y axis. So I'm thinking my ellipse is going to look something more like this, kind of like up and down versus left and right. Nothing else really changes. Kind of everything really works the same. It's just the smaller numbers under X, so that's the minor axis, and the A is under the major axis. A is still bigger than B. B squared equals A squared minus C squared still applies to all ellipses. So we can use this to graph and to find equations and do all that kind of good stuff as well. So let's go ahead and graph a couple. So graphing the following ellipse. Now when I'm doing my center and all that good stuff, I'm still going to start with what's my center and what is my major axis. Now the center, again, nothing really changing x and y, so the center will be at the origin. The major axis in this case is the y-axis, and the reason it's the y-axis is the bigger number is under y. So the other things I need to try to pick out is, can I figure out what A, B, and C are? And from the equation, I should always be able to get A and B. A is 10, because this is A squared. Remember, it's the bigger of the two. And this is B squared, so B is 3. And then I can, of course, calculate what C is, because B squared equals A squared minus C squared. So it's 9 equals 100 minus C squared. Subtract 100, I get negative 91 equals c squared. Divide them both so they're positive, so c squared equals 91. So c is going to equal the square root of 91. And the square root of 91 is somewhere between 9 and 10, 9.4-ish or something. So there is our points. So from that, I should be able to label all my points, get a pretty good graph. So here's my center. So for my vertices, which are 10, now remember the major axis is the y-axis, so it's going to go up and down. So I'm going to go up 10. So 0, 10 will be a vertex. And then down here, 0, negative 10 will be a vertex as well. My co-vertices are going to be 3 units away. So 3 on this side is a co-vertice. That's 3, 0. And then 3 units on this side, negative 3, 0 is a co-vertice. My foci are going to go on the major axis. Again, the major axis is y in this case. So it's up about, I don't know, a little between 9 and 10. So there's a focus. That's going to be at 0, radical 91. And there'll be one down here, a focus, and that's going to be 0, negative radical 91. So now I'll just go ahead and try to graph through the vertices and the co-vertices as good as I can. And there's my ellipse. All right, this next one is similar, but there's a big problem that maybe you see. All the ellipses we've seen in both forms of the ellipse, it has to be equal to just a plane 1. Well, in this case, we don't have it equal to 1. So the first thing I'll have to do is make it equal to 1. So whatever it is, I'm always going to divide by whatever's on the side with the number because I have to make it equal to 1. So 20 divided by 20 will give me x squared over 1 plus y squared over 2, because 10 over 20 reduces to 1 over 2 equals 1. So now I have my ellipse in a better form. So now I ask the same questions as I asked before. What is the major axis? What's the center? Nothing really changing x and y, so we get 0, 0 as my center. My major axis is going to be the y. Rationale, bigger number is under the y squared. So then we also know my a, my b, and we can find c. A is going to be the square root of 2 because this is a squared. B is going to be 1 because the square root of 1 is 1. And then I can certainly find what c is because I know b squared equals a squared minus c squared. So that's going to be 1 equals 2 minus c squared. So negative 1, if I subtract 2, equals negative c squared. Divide by negative 1, they become positive. So c is also going to be 1. So let's go ahead and graph this. So we have a center at 0, 0. Our major axis is y, so we're going to go up and down that value, and that value is only square root of 2, which is about 1.41. So I'm going to have it right there, really, really small vertex at 0, square root of 2. And then one down here, a vertex at 0, negative square root of 2. So this is really, really jammed in here. So I have the advantage I can just make it bigger. My co-vertices are the distance from the center to the vertex is 1. So there's a co-vertex at 1, 0. And there's a co-vertex at negative 1, 0. And my foci are going to be on the major axis. So they're going to be up 1. So I'll have a foci at 0, 1 and a foci at 0, negative 1. So kind of hard to get a good ellipse when it's zoomed in like this, but it looks something like this. We get a little teeny ellipse. The closer a squared and b squared are to each other, the closer it becomes to being circular. If they were to ever become the same, you honestly do have a circle. All right, we can also find equations of ellipses. So let's look at this one. I gave you a graph to kind of go ahead and graph some things, see if you know. So let's find the equation of an ellipse having a focus at 0, radical 17, and an x-intercept at 4, 0. So we're going to assume the center is still at 0, 0. We really don't know what the major axis yet, but we will, because 0 square root of 17, which is like 4.12, is going to be right about here. So there's one of my foci, which is 0 radical 17. So right away, I know my major axis is going to be the y-axis. Because remember, on the major axis, that's where you'll find your vertices and where you'll find your foci. We also have an x-intercept at 4, 0. But if I'm calling the origin the center, then if this is 4, 0 as an x-intercept, it's also a covertice. So that'll help because when I'm trying to define my A, B, and C, well, I know C is square root of 17, distance from the center to the focus, and the distance from the center to the covertice is simply going to be 4. And then I can use a little bit of our equation to figure out what the missing variable A is in this case. So B squared is 16 equals A squared minus square root of 17 squared, which is 17. So in this case, I'll add 17. So I get 33 equals A squared. So A equals the square root of 33 for A. Now, I really don't need to graph that because I'm really just trying to find the equation. So we have x squared and y squared equals 1. So A squared is 33, and just remember, it always goes under the major axis. So in this case, that's going to be y. And then B squared, which is 16, 4 squared is 16, will just go under the minor axis, which is x. So there is my equation for my ellipse. So now we can go ahead and look and we can see what happens if we don't have an ellipse centered at the origin, what instead if it is centered at some point, call it HK. Now similar to how we moved circles and how we moved parabolas, it's really the same idea, is we'll just basically change the x squared and y squared to x minus h and y minus k. The a and b stay the same. If the A is bigger under the X, then it's going to be longer on the major axis horizontally, and vice versa. So in this case, if it has parallel to the x-axis, the a squared is under the x. Over here, the a squared is under the y. You could also write this second one if you want to write h first. You could write as x minus h squared over b squared plus y minus k squared over a squared equals 1. Either way is fine. So let's look at a couple examples where we're graphing these and writing the equations of these kind of ellipses. So this first one, we're writing the equation. It has a new center, it has a center of negative 3, 1, a vertex at negative 3, 3, and a focus at negative 3, 0. So what I'm going to do is I'm going to go ahead and just sketch a little picture. So I have a center at negative 3, 1. So there is my center. And then I'm going to try to figure out which one is my major axis, and then I'll try to figure out what A, B, and C are. Really A and B, I really don't need to know what C is, but we'll see if it's given to us. So we have a vertex at negative 3, 3. So we have a vertex at negative 3, 3. So here is a vertex. So right away, since the vertex is above the center, I know the major axis is the y-axis. Now I put y in parentheses because it's not technically the y-axis. Really, the major axis is going to be the line x equal negative 3, but for simplicity's sake, I'll just say y. We also know the distance from the center to the vertex is 2 units because we're going from negative 3, 1 to negative 3, 3. So I know A is 2. I also know the focus is at negative 3, 0, so this is a focus, also backs up my major axis idea. So I know C is going to be 1. Because the distance from the center to the focus is c. So this actually gives me enough information to finish up because I know b squared equals a squared minus c squared. So b squared is going to equal 4 minus 1, 2 squared minus 1 squared. So b squared will equal 3, b will equal radical 3. So we basically do the same thing. So we'll start with our x squared and our y squared. We're just going to have new things in there, equals 1. So the new things we're going to have to remember the opposite of the center. So we're going to have plus 3 and minus 1. And that's just based on this center here, because it's x minus h and it's y minus k. Now the major axis is the y-axis, so I'll put the 2 squared, the a squared, under that one. And then the radical 3 squared will go under this one. So my final ellipse equation will be x plus 3 squared over 3 plus y minus 1 squared over 4 equals 1. So that is going to be the equation of my ellipse. So same idea, the only thing that really changes is you have a different center, and you also have to just put those in the equation as the opposite of h, opposite of k. So let's look at this last one. Now this last one is an interesting one because graph the following ellipse, 4x squared plus 3y squared plus 8x minus 6y equals 5. This looks totally different than what we've had before. So what we're going to have to do is we're going to have to use the same techniques we use for circles and for parabolas and try to complete the square to get this in a more standard form. So what I'm going to do to complete the square on an ellipse is I'm going to go ahead and take everything that has an x and I'm going to gather that together. And everything that has a y, I'm going to gather that together. Well, that's actually minus 6y. And equals 5 is fine. Now the key is, in each of these problems, whatever is in front of the x squared and the y squared, I need to factor out. So in this case, I'm going to factor out a 4. And for the y term, I'm going to factor out a 3. Reason being, remember, I can only complete the square if I have an x squared with a 1 in front of it. So here's where it gets a little different. So to complete the square, I'm going to take half of b squared, so half of 2 is 1, and 1 squared is 1. So if I add 1 to one side, I have to actually add 4 to the other side. Now, why am I adding 4? Well, if you look at this, I'm adding 1 inside a parenthesis that has a 4 outside. So technically, the 4 has to distribute to that 1. So it's really 4 I'm adding to both sides. Same idea for the y term. I have to add 1. Half of negative 2 is negative 1. Negative 1 squared is 1. But really, that's a 3. So I have to add 3 to the other side. Now, how this benefits me, this polynomial factors, it becomes x plus 1 squared, two things that multiply to 1 add to 2. Same thing over here, it's y minus 1 squared, and you can kind of see our ellipse take shape. 5 plus 4 plus 3 is 12. Now we've had this situation before where we'll have to divide by 12 because we want to make sure in our ellipse we get that 1 over there. So this is going to end up being x plus 1 squared over 3 plus y minus 1 squared over 4 equals 1. So now all we've really done is we've got it in the form of a standard formative ellipse, and this whole complete the square idea on ellipse is very important. So now graphing it, nothing too tricky. The center is going to be the opposite of what's the x and y, so that's negative 1 and 1. The major axis is going to be the y-axis because the bigger number is under the y. A is going to be 2 because this is, of course, a squared, and this is b squared, so b is radical 3. And I don't have c, but of course we know by now we can find it because we know b squared equals a squared minus c squared. So b squared is 3, a squared is 4 minus c squared. So C will turn out to be 1. So based on this, I should be able to find all my points. So I'm going to first start with my center. My center is at negative 1, 1. And I'm going to go up and down from my vertices. So up 2 this way, up, down 2 this way. So I'm going to have a vertice at negative 1, 3, and a vertice at negative 1, negative 1. I really find it helpful to just basically add these things. So I'm really just counting spaces. So radical 3 is about 1.73. So I'm going to go from my center and I'm going to go over here about 1.7 and over here 1.7. Now for the co-vertices, we know we're shifting the x value. So really all I'm going to do is I'm going to take my center, which is negative 1, 1, and I'm going to add square root of 3 to it. And this co-vertice over here is going to be negative 1 minus square root of 3, comma 1. And if I want to do my foci, they're on the major axis, they would simply be up and down 1 from the center. So my foci would be negative 1, 2, and my foci would be negative 1, 0. So there's every possible point you'd ever want on that ellipse. So hopefully ellipses are not too much trouble for you, but if you have questions, obviously, please reach out to me and let me know.